Section 7.2, page 7. We are to find the area of the region above the parabola x squared equals 4py, and inside the triangle formed by the x-axis and the lines y equals x plus 8p and y equals negative x plus 8p, where p is greater than 0. All right, just like always, we have to draw a graph. This one, we have a tough time graphing this because the p is in there. We have some constant p in here, and that's going to affect the size and the scale of this graph, so we don't really know what to do. Let's start right here at x squared. Ooh, I can't see, sorry. X squared equals 4py. So let's come up here and let's solve for y, which means y is going to be 1 over 4p times x squared. Watch your handwriting here and make sure that you see that 4p in the denominator of a fraction and the x squared not. P is a constant, it's a positive constant, so all this is going to change is how narrow or how wide this parabola is. Vertex is still at 0, 0. Let's go ahead and sketch in y equals x squared, and then the 1 over 4p is just going to change how wide or how narrow this parabola is. So there's this one, y equals 1 over 4p times x squared. And let's go ahead and graph these two lines then, y equals x plus 8p. All right, p is positive. So this is some constant up here. If p was 2, this y-intercept would be 16. We don't know what p is, so this y-intercept right here is just some 8p. And we know that this line has a slope of 1, so we'll just go ahead and graph a line that has that y-intercept with a slope of 1. And there's y equals x plus 8p. The other line then, y equals negative x plus 8p, same y-intercept, but this time a slope of negative 1. So we see something like that. Y equals negative x plus 8p. Now we have to find the region that we want, the area. So find the area of the region above the parabola, so up here somewhere, up in here, inside the triangle formed by the x-axis and these two lines. So inside this triangle, but above the parabola, that's all of this in here. Okay, what's important to recognize about this particular shape is the symmetry. So it's the same on both sides of the y-axis. So rather than finding the area over here, which would be top minus bottom, green minus red, plus this part over here, top minus bottom, blue minus red, it's much easier if we just find half and do just one integral of blue minus red and then double it to pick up this other half. And that's exactly what we're going to do. So when we set up this area here, we'll have two of these integrals from 0, because that's where it's going to start, 0 up to, we'll figure out that ending point here in just a couple of minutes, of, and then our top function, blue, minus bottom function, red, dx. And we can go ahead and plug in those functions. The blue one is that negative x plus 8p minus the red one, which is 1 over 4p x squared, dx. All right, we cannot combine any like terms here, so that's it. That's the function that we need to integrate. We do have an issue right here because we don't know that upper bound. And that upper bound is going to be the x coordinate right here at this point of intersection. We need to find that x coordinate right there. That point of intersection is going to be where this blue line meets that red parabola. And since both equations are set equal to y, we can set the right-hand sides equal to each other. And we have 1 over 4p times an x squared equals negative x plus 8p. Multiply through by 4p to clear the fractions. And we'll have x squared is negative 4px plus 32p squared. Then we have quadratics here, so let's pull everything over to the left-hand side. That'll give us x squared plus a 4px minus 32p squared equals 0. Factor, that'll factor into an x plus 8p and an x minus 4p. Remember when we set this up, we were looking to find the x coordinate, so we want x. Solving this, we'll get x is negative 8p and x is 4p. Because p is positive, we know that this one has to be 4p. This negative 8p, that is not this one over here, because we are intersecting this red parabola and the blue line. If you were to extend this blue line out here and extend the red parabola, that would occur at an x coordinate of negative 8p. Our purposes for this problem, we need that x coordinate right there as our upper bound. Okay, now working through, we just need to anti-differentiate this. Don't lose this 2 out here. Antiderivative of a negative x, negative 1/2 x squared. Be very careful here with this 8p. That's a constant. So when we anti-differentiate that 8p, that's 8px. Minus, over here, this is 1 over 4p, that can come down, and then anti-differentiating that x squared is a 1/3 x cubed, and we're going to evaluate this from 0 to 4p. All right, I do want to clean this up a bit first. Here's 2. Negative 1/2 x squared plus an 8px, and this right there is minus 1/12, or 1 over 12p. Be careful that that p is in the bottom still. Times x cubed, evaluated from 0 to 4p. Replace out the x's with this 4p, and we have 2 negative 1/2 times a 4p squared plus 8p times 4p minus 1 over 12p times a 4p cubed. That's just substituting in the 4p. Still need to substitute in a 0. But let's go back and look what happens. When you put a 0 in here, that's 0, that's 0, that's 0. So you're going to get 0 there for all of that. Alrighty, let's see. Don't forget this 2 out here. 4p squared, that's going to be 16p squared times negative 1/2. That's negative 8p squared. Plus, here's 32p squared minus 1 over 12p times, and a 4p quantity cubed is 64p cubed. I'm out of space. I'm going to come up here. 2. All right, I can combine this negative 8p squared and this 32p squared. That's 24p squared. Then look right here. This p here cancels out with one of them up there, so that's going to be a p squared. 12 and 64 we can divide out of 4, which leaves us a 3 and a 16. So all together we have 16/3 p squared. I am going to, oh, it was minus there. I am going to go ahead and get a common denominator so I can add these guys together as soon as I white out this plus sign. 2 and 24 times 3 is 72. So 72/3 p squared minus 16/3 p squared. And 72 minus 16 is 56. That'll give us 112 p squared over 3. Oh boy, what's that? That's the area. That's what we were looking for all the way back up at the beginning. This is your area in terms of P. So if P was 1, then the area of this shape will be 112 over 3. If P is 2, then your answer is going to be 112 times 4. So what's that? 448 over 3. So the area of this is dependent on what that P value is. Whew. All right, one last question here. It says, now find the rate of change of area with respect to P when P is 3. All right, this rate of change of area with respect to P, that's telling you to find rate of change of area, dA, with respect to P, the derivative of area with respect to P when P is 3. All right, well, right here we know that area is 112 p squared over 3. Let's find dA dP. That's the derivative of this. I'm just going to pull that 2 down. That's 224p over 3. That's the derivative, 224p over 3. But now I want you to find dA dP when P is 3. Well, that's just plugging in a 3. 224 times 3 divided by 3. How nice was that? That these are both 3's. So this rate of change of area is 224. And the units here, that's units squared per unit change in P. That means that when P is 3, if P increases by 1 unit, then the area is going to increase by 224 units squared. Phew! We are done with this section. Thank you for tuning in. See you in section 7.3.